Hello, welcome back to lesson 2.6 video notes. This lesson and 2.7 are all about a special type of equation called an absolute value equation. Absolute value, by definition, says the absolute value of a number is a number that will go in, always comes out as a positive. So the absolute value of a -4 is the same as the absolute value of a +4, which is just a +4. So the absolute value, I think about it like a machine, and it doesn't matter if happy things go in or negative things go in, but only happy things come out. It's just the distance it is. So it says, we then can say that if the absolute value of any x is equal to 5, we know that x could go in as a 5 or x could go in as a -5 because just a 5 will come out. So we can extend that thinking to an equation. We can say there is an expression 3x minus 4. When that expression goes in, that expression could result in a negative value and it will come out as a +6, or it could result in a positive value and it will come out as a +6. So that tells us that 3x minus 4 itself could be 6 or a -6. So it could equal 6 or it could equal a -6, because then when you take the evaluation of absolute value of 6 or -6, you get 6, the positive. So let's solve both. So 3x minus 4 equals a +6. If you add 4 to both sides, we get 3x equals 10. And dividing by 3, we get 10/3 or 3.33. Or 3x minus 4 could equal a -6. So look at, to solve for x, we're still doing the same steps. We're adding 4 to both sides. So we have 3x equals a -2 this time. We still divide by 3 again. So when we divide by 3, we get a -2/3 or a -0.667. So the absolute value of 3x minus 4, when does it equal 6? It could equal 6 at 2 spots. And that is because this function, this equation, looks like a V. I'm going to show you Desmos. There's a Desmos link to all of my work in Desmos for this lesson. If you'd like to take a look, it's in Canvas underneath the notes. So here's that intro example. Here is just the equation of y equals the absolute value of 3x minus 4. And so what I did was I wanted you to take a look at that graph. So there's the graph. If you take the left-hand side of the equation and set that equal to y, and then take the right-hand side of the equation and set that equal to y in Desmos, it will show you that intersection where they equal is where they're solved. So we can hover over this equation, this equal sign here, and it shows us the -0.667, which was the -2/3 that we found. See the gray dot where my mouse is? And then on the other one, when I click on it, you have to click on it to get the intersection dot. It's at x equals 3.33, just like we graphed. So let's flip the page in our notes. In this lesson, we're going to do all of example 1 of A through F. So I'm going to go back to my paper here. So A says the absolute value of A equals 5. So that means we know that A equals 5 or A equals a negative 5. Okay, B says the absolute value of X equals a negative 4. And we're going to say not available because nothing negative could ever come out of an absolute value. So we're not going to be tricked by that. Letter C, the absolute value of A subtracting 5 is 2. So we're going to go back to using all of our solving skills that we used in the intro lessons to chapter 2 here. We're going to add 5 to both sides. So we have the absolute value of A equals 7. So that means that A equals 7 or A equals a negative 7. Okay. D, the absolute value of Y plus 3 equals 1. So again, we're going to subtract 3 from both sides. And we get the absolute value of Y equals a negative 2. And we just reminded ourselves up here in letter B that the absolute value of a Y could never equal a negative 2. So there is no such solution. I'm going to show you this for B and D in Desmos so that you can see what I'm talking about. So let's type in D. It's the absolute value. I'm going to use X instead of Y, but it's the same thing. And then it says plus 3. I'm going to turn off my other graphs here. It's the absolute value of X plus 3. And then I'm going to set that equal to Y. And then down here, I'm going to say Y equals 1. So look, the absolute value of X plus 3 cannot ever equal 1. That's exactly what we showed in our example. So that's another not available. Let's look at E. The absolute value of A plus 2 equals 7/5. Okay, so our expression is now inside the absolute value, so we can't do it until we do our ORs. So we know that A plus 2 equals the positive 7/5 or A plus 2 equals the negative 7/5. Now we can solve for A. So I'm going to multiply through by 5 on both sides to eliminate my fractions. So 5 times A plus 2 equals 7/5 times 5. So that cancels. So I'm going to distribute here. So we have 5A plus 10 equals 7. Then we can subtract 10. We get 5A equals a negative 3. And divide by 5, we get a negative 3/5. Or we're going to do the same thing here. We're going to multiply through by 5. So we have 5A plus 10 equals a negative 7. So subtract 10. 5A equals a negative 17. And then we're going to divide by 5. We get a negative 17/5. So a negative 3/5, which is the same as a negative 0.6. And then 17/5 is a negative 3.4, I believe. 17 is 3 2/5. Okay, so we can see this one in Desmos as well. So I'm going to do the left-hand side. So Y equals X plus 2. And then Y equals 7/5. Okay. So I'm going to click on one of the graphs to find their intersection. So there's the negative 3.4, and here is the negative 0.6, just like we said. Okay. So let's go back to our paper here. Letter F. The letter F, we have to set it equal to +1 and -1 first. So we have 2/7 A plus 3/4 equals 1. And then 2/7 A plus 3/4 equals a -1. Okay. So because of the fraction, I'm going to multiply by 28. 28 will eliminate 7 and 4. So 28, 28, and 28. 7 goes into 28 4 times. So 4 multiplied by the 2 is 8A. Plus 4 goes into 28 7 times. So 3 times a 7 is 21. Equals 1 times 28 is 28. Now over here, it's the same equation, except for it's set equal to a -1. So we can multiply through by 28, 28, and 28. And we're going to have the same thing, 8A plus 21, except for on the right, it's going to be a -28 because a -1 times 28 is a -28. Now I can solve for A. We can subtract 21. So we have 8A equals 7. So A equals 7/8. Or subtracting 21, 8A equals a -49. And A equals a -49/8. So in positive 7/8 or -49/8 is my solution there. Then if you flip the page, I'm doing letter J. Oops. I'm sorry, flip the page. It's letter B. We're now looking at, I'm sorry, letter J. The letter J says 7 equals the absolute value of 3/5 x plus 1/5 plus 2. So I have to isolate the absolute value first by subtracting 2. So we get 5 equals the absolute value of 3/5 x plus 1/5. Okay, so let's set them equal to 5 and a -5. So either I have a -5 equals 3/5 x plus 1/5, or I have a +5 equals to 3/5 x plus 1/5. So I'm going to multiply through by 5 to get rid of my fraction. So that gets multiplied through by 5. This gets multiplied through by 5, which cancels. This gets multiplied by 5, which cancels. So I have 5 times a -5 is -25 equals 3x plus 1. So to solve for x, I'm going to subtract 1. Is a -26 equals a 3x. And then dividing by 3. I get x is a -26 thirds. And then over here, I'm going to do the same. I'm going to multiply by 5. Those will cancel, multiply by 5, that cancels. So over here, I have a positive 25 equals 3x plus 1. If I subtract 1, I have 24 equals 3x. And then we divide by 3, and we get x equals 8. So either x equals a negative 26/3 or x equals 8. Remember the other questions up here, G, H, and I are all on the extra video. Then there is one last little piece. It's when an absolute value is set equal to an absolute value. So if that happens, then we do these two things. We take what's the expression of A is equal to the positive expression of B, or the expression of A is equal to the negative of B. So they equal or the opposites equal. Okay. So for example, 3x plus 2 absolute value equals the absolute value of 2x plus 3. So either their insides equal as is, or the inside of A equals the opposite of the inside of B. So let's look at example 3a. So we have either 5a plus 2 equals, that should be 4a plus 7, not z. Or we have 5a plus 2 equals the opposite of 4a plus 7. So let's do the where they equal each other. So I'm going to move my x's to the left. I'm going to subtract 4a. So I have a plus 2 equals 7. And subtract 2, we have a equals 5. Or the opposites over here. So we'll have 5a plus 2 and distribute here. We get a negative 4a minus 7. So again, I'm going to move my negative 4a over. So now I'm going to be adding 4a. So I have 9a minus 2 equals a negative 7. And if I add 2, oh, no, that's adding 2. So I have to subtract 2. So we end up with 9a equals a negative 9. Dividing by 9 is a is a negative 1. So let's look at that in decimals. Let's show that when these two absolute values equal each other, they equal at 5 and a negative 1. Let's put this in. Okay. So we have, I'm going to let the left is 5x plus 2. And then y equals, and then the right is 4x plus 7. And I'm going to turn off all this other stuff that we don't need. And then we want to know where they equal each other. So this goes parallel. So they touch each other here, which is at the negative 1. And then they touch each other here, which is at 7. What did I mix up? Oh, no, they don't touch each other there. That's the x-axis. Okay, so I have to zoom out. So we found the first one down here at a negative 1. And then it looks like they cross again up here. So where did they cross? There it is at 5, like we had found. Okay. Let's go back to our paper here. Then letter B. So either they equal each other at positives or they equal each other as opposite. So 1/10 x minus 1/2 equals 1/5 x plus 1/10. or 1/10 x minus 1/2 equals, and then it's going to be the opposite. So it's going to be, and to save time, I'm going to, in space, I'm just going to multiply through by the negative. So negative 1/5 x minus 1/10. That's the opposites. So I'm going to multiply through by 10 because 2, 5, and 10 are all multiples. Have 10 as a multiple of each of those. I'm going to do that. That's going to work for both equations. So they cancel there. 2 goes into 10 5 times. 5 goes into 10 2 times, and they cancel there. They cancel there. 2 goes into 10 5 times. 5 goes into 10 2 times, and they cancel there. So on the left, we have x minus 5 equals 2x plus 1. So I'm going to move my x's to the left. So I have a negative x minus 5 equals 1. And I actually created a new step for myself by doing that. So you could move the x's to the right. I have a negative x equals 6. And then if we divide by a negative 1, we find out that a positive x equals a negative 6. Oh. Okay, so over here we have x minus 5 equals a negative 2x minus 1. So now I'm going to move my x's to the left again. So I'm going to add 2x. So we have 3x minus 5 equals a negative 1. I'm going to add 5. So 3x equals 4. And then when we divide by 3, we get x is 4/3. So x is either equal to a negative 6 or 4/3. And the other examples, E, D, and E are all on the extra video. So watch me back for lesson 2.7.